Welcome to Space Train. What if I told you that a 10-second handshake could transfer a person's DNA to an object that the person never touched? In handshaking experiments, people who never picked up a knife became the major source of DNA on the handle about 7% of the time, forensic scientist Cynthia Kale reported February 21 of 2019. At the annual meeting of the American Academy of Forensic Sciences, that DNA was transferred to the knife when the person's handshaking partner grasped the handle. In a separate study, the last person to touch an object such as a communal pitcher was often not the one who left the most DNA behind. Leanne Reiser, a forensic anthropologist who did the work at the University of Indianapolis, reported at the meeting. The findings suggest that even brief contact with another person or object could spread DNA far and wide, which could complicate crime scene investigations. While the results don't mean DNA evidence is unreliable, Reiser and Kale said, investigators should be careful to account for these accidental transfers. In real-world situations, it's probably rare to find people's DNA in places they've never been or on an object they've never handled, says forensic geneticist. Left-behind DNA is usually unstable and breaks down with time, she says. We can't discount the idea, but we shouldn't use it to throw the evidence out in every single case. Previously, Kale, of the Houston Forensic Science Center, found that shaking hands for 2 minutes could transfer one person's DNA to an object by way of the other person's hand. But many critics said that 2 minutes is an unrealistically long time for a handshake. In the new experiments, Kale shortened the handshaking time to 10 seconds. Even briefer contact might also transfer DNA. In Reiser's experiment, 4 University of Indianapolis students sat around a table and poured beverages from a communal pitcher. Other students watching the experiment were free to leave the room, talk and move around to simulate conditions in a restaurant. As each student at the table handled the pitcher and a plastic cup, researchers swabbed the pitcher handle, cups and the students' hands for DNA. DNA from students at the table was on the pitcher handle and on each other's cups, even though the volunteers handled only their own cup and the pitcher. What's more, DNA from other students in the room showed up, too, but none of the observers had touched the students at the table or the pitcher or cups. Observers' DNA may have spread to the cups and pitcher through tiny spew droplets as the onlookers talked, coughed or sneezed. Looking at the amounts of DNA left behind on the objects, the researchers couldn't determine who handled the pitcher last, nor could they pinpoint how long a person touched the pitcher or cup. The results demonstrate that DNA can transfer easily in social settings and in unpredictable ways. Some of those results may be explained because people shed DNA at different rates, Prince says. But it's still not clear how often that type of transferred DNA might skew crime scene investigations. We're all still trying to get a handle on how realistic this is. So be careful when next time you decide to shake hands. Your DNA can be used in lots of unexpected places you don't want to be part of. That's all today. Follow our train to stay updated on new science discoveries.